Question number 3 was a system of equations. I said you can use substitution or elimination. So which route do you guys want to take here? Substitution or elimination? Substitution? Okay, which one would you pick to solve for then? The y and the second one. I agree with that. So if I get my y by itself, I get y equals 3x plus 18. Then I am subbing that into the first one. So the first one is 2x plus 3 times the y, which we are plugging in 3x plus 18, equals 10. So if we distribute, we get 11x. We subtract over the 54, divide, and x is -4. Make sure you are correcting any mistakes as you go through. All right. Then we have to find our y, so we can plug it back in right here. We know y is 3 times x plus 18. So y is 6. So my answer is -4/6. Fix things if needed as we're going through. Okay. Question number 4. So we have a system. This one was harder, really almost because I didn't give you every variable in each equation. So the first one we had x plus z equals 2. The next one, 2y minus z equals 2. And then negative z plus 2y equals -4. All right, so we tried substitution or elimination. Yesterday when I was walking around, most people were putting the first 2 equations together to start, which is great. So when we add those together, the z's cancel. I can't add x and y, so it's just x plus 2y equals 4. All right. Then the next one, we have to use the third equation because we haven't yet used it. We notice it has a z and a y. So I can't put it with the answer I just got, right? I have to put it with one of the others and eliminate the same variable. I just eliminated z, so I need to eliminate z again. So maybe I put it with the first one. So the first one was x plus z equals 2. This one I have negative z plus 2y equals -4. When you add, you're adding like terms. A positive z and a negative z would cancel. So I get x plus 2y equals -2. If you look at it, now I have 2 equations that have the same variable. So what do? Put them together. All right, if I want to eliminate x, I could take the first one times the -1. So I get a negative x minus 2y equals -4. This one, x plus 2y equals -2. When I add together, Negative x and positive x cancel. Negative 2y and positive 2y cancel. So I get 0 equals negative 6. What does that mean? No solution. That is a false statement. 0 is not negative 6, so we say no solution. Inconsistent. The direction said to identify any inconsistent systems. So we have to say no solution, inconsistent there. Is that one okay? How do I know the difference between like a no solution and an infinite solution? Right. If I added it and I got like 0 equals 0, that would be the case where there are infinite solutions and we have to write the ordered pairs in terms of whatever variable. And this one it said that in the directions in terms of y, if that occurs. All right. Next question. Number 5. Again, we have 3 variables, 3 equations. So we're going to have to do substitution or elimination repeatedly here. Make sure you keep your work organized. That's really the biggest problem that we saw with these. So you're going to take 2 equations and eliminate a variable. So if I took the first 2 equations, what variable do you want to eliminate? Y. So to do that, I'd have to take the first one times 5. So I get a 10x minus 5y plus 20z equals negative 5. Second equation, we kept the same. When we add these together, 10x plus negative 3x will be 7x. Negative 5y and positive 5y cancel. 20z minus z is 19z. Negative 5 plus 5 is 0. Are we fixing these as we go along? You have not yet used the third equation, so I have to use that, and I have to eliminate the same thing, so I have to get rid of y. So if I'm getting rid of y, I'd probably pair that with the first one. What would I have to multiply the first one by this time? I get 6x minus 3y plus 12z equals negative 3. And 2x plus 3y plus 2z equals 3. Add those together, we get 8x plus 14z equals 0. All right, at this point, I now have 2 equations that both have x and z. So I should be able to use those to eliminate something. What do you want to eliminate? X. Okay. So if I do that, I'm going to have to multiply both equations by something. I'm going to have to take the first one times, let's say, negative 8, and this one times 7. So that gives me a negative 56x. What's negative 19, or sorry, 19 times negative 8? Okay, second equation times 7, so we get 56x plus when I add, my x's cancel, I get negative side, and z is 0. So once I have z, we can start working backwards. So you can plug it back into one of these. If I just put it in right here, I know 8x plus 14 times 0 equals 0. So 8x equals 0, so x is 0. All right, now I have x and z. So if I go back to one of the originals, let's just go to this third one. X is 0, z is 0. So I get 3y equals 3. So y is 1. When you write your answer, it's alphabetical order, x, y, z. So 0, 1, 0. Questions on that? Number 6. So now we're into our nonlinear. Okay, the idea is the same. Substitution and elimination is going to be the route to go. This one, if I'm looking at it, I have an x and an x squared, so I probably want to keep that, so I would eliminate y. How would I eliminate my y? Yeah, you could multiply by -1 or just think of subtracting that one when you go through. So that gives me a 2x minus y equals -10. X squared plus y equals 13. So when we add, these aren't like terms, so it's just x squared plus 2x equals 3. So we can bring over the 3. Okay, multiply to -3 and add to +2 would be a +3 and a -1. So we set those equal to 0, we get -3 and 1. Okay, I have two x's. These are separate. So in one order pair, my x is 3, and one order pair, my x is 1. Now I have to plug those in. So if I put in a -3, if I just go with the first one, so -2x plus y equals 10. So then we get y to be 4. If I plug in a 1 for my x, then I get my y to be 12. So we have -3, 4, and 1, 12. How do we check these if we want to? Plug them back into the original. I think I'm going to go ahead and work out problem 7, just because I want to make sure we're writing our answers correctly. Okay, both equations have x squared and y squared. So if I wanted to eliminate x squared, what would we do? add these together. X squareds cancel, so I get y squared equals 4. Square root. If you add a square root, that's when you need plus and minus. So we have two y answers, positive 2 and negative 2. So my ordered pairs, I currently have 2 points. One when y is 2, one when y is negative 2. You have to plug this back in. And you can go with either equation if I just go with the bottom one. Then I get x squared equals 9. When I square root, again, if you add a square root, you have plus or minus. So I get positive and negative 3. So what does that mean? Right. When y is 2, x could be 3, or when y is 2, x could be negative 3. So that just gave me 2 points there. When I plug in a negative 2, the same thing happens. So we have x squared plus 4 equals 13. So x squared is 9. Square root plus or minus. So it could be a positive or negative 3. That's when we get the 4 points. I had 2 values for y, and when I plugged each of those in, I got 2 values for x. Does that make sense to everybody? Okay. Number 8. This one is really hard to do with elimination because we really have too many different things. We have an x squared, a y squared, an x and y multiplied together, an x and y by themselves, and there's just too much stuff to eliminate here. So that means substitution. What would you try to solve for? X and the second one. So x would be 3y minus 2. So now we are going to plug that into the first one. Okay, so this was x squared. So that's 3y minus 2 squared. Plus 2 times the x, which is 3y minus 2, times my y. Alright, so you have to think a little bit here. 3y minus 2 squared means we have to FOIL it out. So we get 9y squared minus 6y minus 6y would be minus 12y plus 4. Here, if you distribute your 2, you have 6y minus 4, but that's all still multiplied with y. So if I take my y through as well, we get 6y squared minus 4y. All right, a little bit ugly, but if we combine like terms, 9y squared plus 6y squared plus 1y squared, so 16y squared. Negative 12y and negative 4y, so minus 16y. What happens if I subtract over my 4? Those cancel. GCF, what can I take out? So if we set those equal to 0, we get y to be 0 and 1. So 2 points. 1 when y is 0, 1 when y is 1. We have to plug them back in to get x, but we know x is 3y minus 2. If I put in a 0, we get negative 2. We put in a 1, we get 1. Any questions on that? Is this helping, guys? 9 and 10, that's the most recent thing, the system that we had to graph. So if we are going to graph these, we want to get them in y equals mx plus b form. So this would be negative x plus 6. So y-intercept of 6. Slope is negative 1, so down 1 over 1. How do I know if it's solid or dashed? If it has an equal to, it's solid. This one does not. The first one was just less than, so it's just dashed. You might recognize that less than is below. If not, do a test point. You put in 0, 0. You get 0 is less than 6, which is true. 0, 0 is down here, so we are shading that side of our line. Second one, if I'm solving for y, I subtract my 2x. When I divide by a negative, what happens? So this one has a y-intercept of -3. Slope is 2, so up 2 over 1. It would be a solid line because we had an equal to. All right, and then we have to decide where to shade. So if you put in a point, like 0, 0, you get 0 is less than or equal to -3, which is false. 0, 0 is right here, that's false, so we're shading on the other side. So our overlap region is this right here. And remember, you have to make sure that's darkened in so I can clearly tell where your solution is. So first one is already set up in y equals mx plus b form. Y-intercept is -2, slope 1/3. 1 over 3. It would be a solid because of the equal to. If you did a test point, you get 0 is less than or equal to -2. True or false? False. 0 is not less than -2, so we can't shade 0, 0. So we're shading this side of our line. For the second one, you could think of this as a parabola, like think -x squared plus 5. -x squared is an upside down parabola. The 5 moved it up 5. Make sure on your graphs that you have exact points. How many points did I always say had to be exact? 3. So could you just plug in points if you needed to? Yeah, absolutely. If you put in a 0, you get 5. Okay, if you put in a 1, 5 minus 1 is 4. If you put in a -1, -1 squared is 1, so we're getting 4. If you wanted, you could put in a 2. 5 minus 4 is 1. Put in a -2, you also get 1. So we're getting this upside down parabola. It would be dashed because there was no equal to. Okay, if you try your test point, 0, 0, you get 0 is less than 5, which is true. So that means 0, 0 works, so we are shading inside our parabola. So my overlap is the inside of this parabola underneath the line. Fix any mistakes. Everybody should have a perfect study guide by the time we are done today. Questions on that one? 11, we were good on 12. Okay, there's really two ways of doing this. You could set it up like equations and just write an equation for each variable, or you could just go ahead and get that matrix by itself. What would this 4 do? Okay. If I wanted to move this matrix to the other side, what would I have to do? Okay, so we can subtract. 12 minus negative 3, so 12 plus 3 is 15. 16 minus 2 is negative 18. 8 minus 5 is 3. 20 minus 1, 19. Negative 4 minus 0 is negative 4. 24 minus 4 is 20. Have I lost anybody there? Okay, sorry. So we multiply the 4 through, and we subtracted that matrix. At this point, if I'm trying to get this matrix A, B, C, D, E, F by itself, what do I have to do? It's multiplied by 2, so we have to divide by 2 on both sides. So to divide a matrix by 2, you're just dividing every number by 2. So I get 15 halves, negative 9, 3 halves, 19 halves, negative 2, and 10. And so now we know all of our numbers. They're just in the corresponding spots. So A is the 15 halves, B is the negative 9, C is the 3 halves, D is the 19 halves, E negative 2, and F is 10. All right, is that one okay? We did not ask about both of these, but I am going to work out both 13 and 14. These are your multiplication ones. And if you forget how to multiply, then you just missed quite a few points, because every entry here would be a point. So I want to make sure we remember what we're doing. We first have to make sure we can multiply them. So we do the size. What's the size of the first one? What about the second one? So if these numbers are the same, we can multiply them. The size is here, 3 by 2. So 3 rows, 2 columns. All right, we have to find each of these numbers. So what we do is a row times a column. So you do 1 times negative 1, which is negative 1, plus 2 times 2 is 4. Negative 1 plus 4 gives me a 3. Strongly encourage you to show me a little bit of work on this on the test rather than just writing down, because if you're multiplying something wrong, you could still get partial credit if I have work to look at. Then, go to the next one, row times a column. So 1 times 0 is 0. 2 times 5 is 10. 0 plus 10 is 10. Fix any mistakes. We're done with the first row. So now we are on to the second row. So I'm using this one to get everything. So the first row times the first column. 3 times negative 1 is negative 3. 0 times 2 is 0. Negative 3 plus 0 is negative 3. Next one, 3 times negative 1 is, 3 times 0 is 0. 0 times 5 is 0. So that row gives me a 0. And so we use the second row in the matrix to get our second row down here. We use our third row to get the third row down here. So negative 6 times negative 1 is 6. 5 times 2 is 10. So if we add those, we get 16. Negative 6 times 0 is 0. 5 times 5 is 25. Add and we get 25. So that is our final answer. So checking to see if we can multiply. What's the size of the first one? 3 by 3. And the second one? These are the same, so we can multiply. My final answer will be a 3 by 3. All right. So to get the first row of my matrix, I use the first row here. And I'm going to multiply that by my first column. So negative 2 times 1 is negative 2. 5 times negative 1 is negative 5. 5 times 1 is 5. Add all that and we get negative 2. Second one, negative 2 times 0 is 0. 5 times 0 is 0. 5 times 1 is 5. So that gives me a 5. Third one, negative 2 times negative 1 is 2. 5 times 0 is 0. 5 times negative 1 is negative 5. Add and we get negative 3. Are you guys understanding where these numbers are coming from? So to get the second row, we use the second row of that first matrix times each of the columns. So 0 times 1 is 0. 1 times negative 1 is negative 1. 4 times 1 is 4. Add and we get 3. 0 times 0 is 0. 1 times 0 is 0. 4 times 1 is 4. Third column. 0 times negative 1 is 0. 1 times 0 is 0. 4 times negative 1 is negative 4. Then we're on to the third row. So we take that row times each column. So 3 times 1 is 3. Negative 4 times negative 1 is 4. Negative 1 times 1 is negative 1. Add that together and we get 6. 3 times 0 is 0. Negative 4 times 0 is 0. Negative 1 times 1 is negative 1. And the last, 3 times negative 1 is negative 3. Negative 4 times 0 is 0. Negative 1 times negative 1 is 1. All right. Do we all understand how to do multiplication? The last two, I think we can get through them, are word problems. These were the ones that walking around we had a lot of trouble with, so let's make sure we get it fixed. A total of $5,000 is invested at 2%, 3%, and 4%. We are going to be asked to find the amount at each rate, so you define your variables. So x could be the amount at 2%, y the amount at 3%, z the amount at 4%. Okay, it said we have a total of $5,000, so what's my first equation? The amount invested at 4%, so the amount at 4%, that's z, equals the total amount invested at 2% and 3%. So z is equal to x plus y. Third, the total interest. So interest is when you take the rate times the amount. So the 0.02x, 0.03y, 0.04z is 165. Now we have to find the amount at each rate. So we can do substitution, elimination, whatever we would like. If I wanted to, what do you guys want? Did you do substitution or elimination? Substitution. So I'm assuming what you did is probably subbed this z into both of those equations to start. Okay. So if you did that route, the first equation becomes x plus y plus x plus y equals 5,000. So that's 2x plus 2y equals 5,000. I also need to put that into my last equation. So replace the z with x plus y. So we multiply out the 0.04, add like terms, we get 0.08x plus 0.07y equals 165. All right, we are actually in pretty good shape because if you look at these two equations, what do they have in common? They both have x's and y's. Oh, that's not 0.08 though, is it? That's 0.06. You guys are just going to let me go with it, huh? Okay, so if I wanted to eliminate x, maybe I'm going to multiply this one by negative 0.03. So then I have a negative 0.06x minus 0.06y equals negative 150. And then my second equation. Add those together, x's cancel, so I get 0.01y equals 15. Divide, and so y is 1,500. Okay. We are running short on time. Do you guys know how to plug this in to get the other two? Okay, so when you work backwards and plug them in, you should get the x to be 1,000 and the z to be 2,500. What do you have to do after that? Yes. Okay, so I just wrote down the answer here, but everyone knows how they would finish it? Okay. Let's talk about at least the setup for the final one. So, we are selling sugar cookies and double chocolate chip cookie dough. So, x could be my sugar, and y could be the chocolate. Alright, we know that Beth sold 11 packages of sugar cookies, so that's 11x, 12 packages of chocolate chip, so 12y, whoops. And the total was $127. Stephanie had 1 sugar cookie, 14 chocolate chips, so 14y, and that was equal to 89. And then how would you finish it from here? Substitution or elimination. Either solve for x in the bottom one, or maybe multiply the bottom one by -11, and you should be able to solve. And then once you do that, you should get that your x is $5, y is $6,